All right, well, welcome everybody joining us this afternoon. We hope you had a wonderful week and we're excited to be here with you this Friday. This is a really exciting partnership for us at the Fairbanks Museum to be working with the Girl Scouts of the Green and White Mountains. My name is Drew Bush and I'm the Director of Programs at the museum. In a moment, we'll just turn things over to our amazing presenter, Hannah Buckner, who's gonna help you work on a couple of your badges over the next 3 to 4 weeks. First, just wanted to ask you if you're on our Facebook live stream over at the Girl Scouts of the Green and White Mountains and you'd like to ask questions during today's session, make sure you use the chat box there on Facebook and make sure that you also include your name and your location, so where you currently are watching this live stream from. So without further ado, I just wanted to turn things over now for Hannah Buckner to begin with our class for Brownies. And she'll say more about the badge that you'll be working on.
Thank you. And Drew, if you could turn on my video, that'd be great. Sorry. Great. Great. Thank you. Well, now you can see my face. So thank you everyone for joining us today. With this Brownie group, we're going to be working towards your Space Science Adventurer badge for the next 4 weeks. Today we're going to be talking about the solar system, and we're going to be able to learn how to develop and use a model to describe and represent the order of our solar system. And we're going to also be able to talk about the different celestial bodies or the objects that are in the solar system. So we'll be able to talk about the planets, our sun. We're also going to talk about the moons that might be in each group, because most of the planets have moons. We're going to talk about some of the 5 dwarf planets that we have, and we'll talk a little bit about what that means. Kind of show you where the comets and asteroids live and how we have rocks, ice, and dust in our solar system. So before we get started, I just want to let you know that you will have access to a document that is entitled GSGWM Brownie Group Week 1. That will give you kind of an overview of what we've talked about today once class is over. It has the overview of what I just said, so what we're going to be doing today, the objectives. So our objectives today are to understand what the solar system is orbiting around the sun. At the end, you will be able to name all of the 8 planets, and you will also be able to know the types of planets in our solar system. There's an activity at the end, and I've provided the materials that you will need to get or gather, as well as a website that we will be using in class today for you to play around with when we're done, and you may want to check that out. And then there are highlights for this lesson, and I encourage you to take a look at that afterwards, and there's a little bit of homework. But I encourage you that when you are doing that part, try to do it as best you can without any help. And when you're done with that, try to do the activity. And if you have any questions, feel free to reach out to me or Carrie, and we'll try to help you along. So let's get started. First off, we are going to be looking at the sun. And so I found this really cool tool that I believe is really great for seeing kind of what our solar system looks like right now. And it's really great. And I just have to pull it up so that we can actually see it. Just let me start it, and then I can share this. There we go. So you should be seeing a website starting up saying, "Welcome to the solar system." And this is really cool because it's showing us what the universe is looking like right now. So welcome to our solar system. We're going to start off first with the sun. And the sun, you may not know, is a star. It is a star that burns this thing called, sorry guys, hydrogen. And as it's burning hydrogen, it has this reaction in it that makes it burn, and it shines, and it gives off heat to live. We get to have heat that warms the sky, and we have plants that can get sunlight and use that to get growing, and it's so important for us to need the sun. And the sun is at the center of the solar system. As we move out here, you'll see that the solar system is quite big, and we can't see it, but there's going to be something around here that is going, that we're going to talk about, that you can't see in this model, but it looks really, really cool. Sorry. So, it's so pretty. So as we go back in, still figuring this out, you'll notice that there is this little gray circle that sits really close to the sun. And as it goes around, and we're gonna do about 1.9 days per second. So for every second that we see this moving, it's about 1.9 days. And so you'll see the Earth is spinning really fast and it's moving. So this right here is Mercury. It's the first planet of our solar system. It is tidally locked, which means that it doesn't have, the sides of its faces don't move. It is always facing, the same side of its planet is always facing the sun. So it's very hot and it's very small. It is a rocky planet, also known as a terrestrial planet, which means it's got a core that's pretty big, that's probably made up of iron and nickel, and it has a crust like the Earth does, and it is made up of rock. There was probably never a time where there was water or land. It's not a safe place to live, but it is still one of our solar system. The next one that we'll see, if we are going by circles, and these circles kind of tell us the shape of the orbit or the path that a body takes around another object. So if we're looking, the next one is Venus. It's the second planet. And there is a guess that Venus was once like our planet, Earth. It's around the same size as Earth. Venus has also a rocky core like Mercury and has a surface, but because of some gas problems, Venus actually has a really thick atmosphere, or the level of air and gas that is on the planet. So just like how we have an atmosphere where we can see sky and clouds and birds can fly through, we have an atmosphere. Venus has that as well, but its atmosphere is much thicker, much denser because of a condition called greenhouse gases. And so it's very hot and doesn't really orbit all that much. So Venus would be a very awful place to live, because if you were to be at the center of this planet, you would probably be crushed into a pancake. However, if you lived on Venus during, if you lived on Venus in between levels of clouds, you can actually float if you were on a cloud city like in Star Wars. So that's the second planet. You might recognize the third planet, also known as our lovely home. This is Earth right here. And Earth is the first planet that is closest to the sun that has a moon. And we do know this moon as the moon. That's how we actually named everything else a moon. They are called satellites, or objects that orbit around a home or a body. So the moon's home is Earth, and then the Earth is home in the sun. So Earth, as we know, is our home. It takes 365 days in a year to orbit the sun, one round completely. So if the Earth were to start here and were to go around all the way around again, and to get back here, it would take 1 year. and it rotates around its axis, or the center right there. It rotates in 24 hours or 1 day. And so the Earth has a satellite called the moon. And we see the moon every month, and it goes through phases, and it's quite pretty. Next is Mars. Mars is the fourth planet from the sun, and it's a beautiful red and orange color right here. And if you see that little white spot right there, that white spot is an ice cap. And so Mars is also thought to be just like Earth, as Venus is thought to be. And Mars has very little atmosphere, so it's very cold, unlike Venus. So it's on the other opposite side of what Earth could be. It's beautiful, and it's the only planet that's currently inhabited by robots that we sent there, but it's pretty cool. And Mars has 2 moons, but I don't think we can see them right now. And they're the size of asteroids. They're actually captured asteroids that are now stuck as satellites around Mars. And then, so that is the end of all of the terrestrial bodies, or the rocky planets around the sun. But you might be wondering, Hannah, what is this? What is that? Ceres, what is that? That looks like a rocky planet. Well, it is, but it's not a regular planet. It's a dwarf planet. And dwarf planets are just like planets. They're typically rocky planets, terrestrial planets, but they're very small, very, very, very small. They're almost, it's about the size of Mercury. And, but you'll see that it kind of lives with the rest of these asteroids. Now, this is called the Asteroid Belt. And so this kind of tells us that, sorry guys, this tells us that this dwarf planet is probably an asteroid that just got shortened out as a planet. Okay, so next we see that we've talked about Mercury, Venus, Earth, and Mars. And Earth and Mars have 2 moons, and we saw already a dwarf planet. So out of 8 planets, we've already talked about 5. So there's going to be 3 more. So if we're looking at the next circle, there's 1, 2, 3, 4, 5. Jupiter is the 5th one. Now Jupiter is quite famous. Jupiter, I don't believe we'll be able to see it too closely, but Jupiter, let's pause this. Jupiter is a big planet. It's a very big planet. And it's got all these stripes, and actually you can see it right here. If I can somehow move this so I don't make everybody motion sick. No, I can't. You'll see that there's a big red spot right here. This is called the Great Red Spot. I love scientists. They make it very obvious. It's actually a very big storm. And so this storm is just like a really bad hurricane, but it's the size of Earth. So it's very big. It's a very big storm, and I don't remember the speed of it, but it's really bad. It's really windy. It would probably be 10 times worse than our Category 5 hurricane, which we know caused a lot of damage here on Earth. This kind of planet is called a gas giant, which means it's got a very small core, but it's got massive, massive amounts of gas. And so its atmosphere is so thick that it would probably take a very long time just to fall through the gas to reach the core. But even if you reach the core, you would also be crushed into a pancake, like if you were on Venus. Jupiter has quite a number of moons. I believe Jupiter has 72 moons. No, 79 moons. It's got 79 moons, which is a lot. And they all orbit Jupiter. Some of them are very close and some of them are very far. So if we step back from Jupiter, you'll see that there's another planet. So this has got to be, if we did Mercury, Venus, Earth, Mars, Jupiter, Saturn, this is the 6th planet. And this is also a gas giant. And you'll probably recognize Saturn pretty quickly because Saturn has rings, and it is known for being bright yellow and having such gorgeous rings. Rings of Jupiter actually have dust and ice and rock in it. And so when you actually, if you were to actually go to the rings and try to catch one with your hand, they're only the size about a baseball. So they're not that big. But they can range from size from a baseball to maybe the size of my desk, which is probably about 3 feet. So they can be pretty big, but they're not really that big in comparison to the rest of space. So they may seem big to us, but not that big. And Saturn has 82 moons, so even more than Jupiter. And that's not even the most accurate number. There's probably even more. Jupiter and Saturn, we're always discovering more moons, which is kind of why also we need scientists to always be looking at them. We already know so much about them, but there's still so much more to learn. And then there are 2 more planets that we have to talk about. So after Saturn is another planet, and we call this one Uranus, or as you would say in Latin, Uranus. I can bring it up. There we go. So Uranus is really pretty. Let's see if I can pull that one up. Oh, I didn't know I could do that. Wow, we're learning things together, guys. So this is a really cool planet. It is orbiting the sun on its side. So I guess if my head were a regular planet and I'm going around the sun, if I was Uranus, I would be orbiting like this, going around the sun. And so it's got rings just like Saturn, and actually Jupiter does have rings, but they're very minuscule or small, so we don't see them. Uranus has 27 moons, but we're only seeing a few of them here. It's a beautiful blue. It kind of looks like a pearl. And it's very far from Earth. I mean, from Earth and from the sun. And then if we were to go out even further, we're seeing Neptune. Now, Neptune is the last planet of our sun. Well, the last regular planet for our sun. Neptune is also blue, and you can see some of the clouds on it, and there also is like a little storm that you would see with Jupiter. And this one is also very far away. Neptune has 14 moons. And it also looks like a little marble. So we've talked about all of the planets that are in right now. So we know that the terrestrial planets are Mercury, Venus, Earth, Mars. And that means they're all rocky. And then we have the asteroid belt, which is composed of asteroids. That's why it's called the asteroid belt, and that's between Mars and Jupiter. And then, so Jupiter marks the start of the gas giants. So we have Jupiter, Saturn, Uranus, and Neptune. And they're all really big and gassy. But I said there was also dwarf planets, and we saw Ceres. So what about the rest of them? So if we want to see all of the rest of them, there's actually something cool that we can do with this. I think this is it. No, that's fine. We can see the other dwarf planets. And so if you see these little orange-brown lines, these are showing the paths of the stars. And so we see Ceres, and there's also Pluto. And so, you know, we saw these planets, and we also saw Ceres. So why is Pluto considered a dwarf planet? There's always just like these arguments as to why Pluto was no longer a regular planet. And so you'll actually see that Pluto is really small. It's really not that big. It's also like Ceres, where it's very, very, very small. It doesn't look like an asteroid, but it doesn't have the same qualities as the rest of the planets. And so that's why NASA demoted it or lowered its rank from a regular sized planet to a dwarf planet. But that doesn't mean they're less important. Dwarf planets are really great, and they make up a lot of the planets that exist in space. And so there's 3 other dwarf planets that we can see with this simulation. We see Eris, we see Makemake, and we also see Haumea. Now, these are commonly forgotten about because when we talk about our solar system, we usually are hearing people talking about our sun and just the planets, but our solar system is much more than that. We see that we have 5 exoplanets, we have the 8 planets, and we also have, hang on, I want to see the sun. I want to see the sun. I haven't seen the sun in days. Okay, so as we go out from the sun, we saw, what did we see? We saw the asteroid belt. Where is it? I guess we can't see it now. Great. Well, there was the asteroid belt, and that asteroid belt was the barrier between Mars and Jupiter. And then we saw that beyond Neptune, there was another kind of belt-looking thing, and that's called the Kuiper belt. And that's home to more asteroids and also these things called comets. Now, asteroids, I've been saying a lot about them, but what are they? They are pieces of rock and dust that collected together when our solar system was forming about maybe 4.5 billion years ago. That's a very long time. They're just pieces of rock that have clumped together, and they kind of stayed at these specific distances from the sun. Comets are kind of similar, but they can be a little bit bigger, they can be a little bit smaller. They also have ice in them. And so when they get closer to the sun, or they get pulled out of their orbit to orbit the sun, or to like move around the sun in a different path, we'll see that their ice will start melting, and they leave these beautiful streaks behind. And so they are also very important to our solar system, as they can also impact our orbits. So everything wouldn't be as it is without all of these parts. And so when you are going to be doing your activity later, you'll be seeing where everything is. You'll have all the planets, then the asteroid belt, and then the Kuiper belt, and then I don't believe that you'll be talking about it with the activity, but beyond the Kuiper belt is a cloud that encircles the whole solar system, and it's called the Oort Cloud. That's where most of the comets live. And so you'll see just how far all of this is, and soon you'll be able to understand kind of just how the universe is spaced out. I mean, our solar system is spaced out, and learning more about that. So thank you guys for listening. If anybody has any questions, I'll be happy to answer them right now.
Just a reminder that if you're on our Facebook live stream, you can use the chat right over there. I should say actually the Girl Scouts of Green and White Mountains Facebook live stream. You can use that chat and ask your questions right there, and we'll be able to see them and get them answered for you before we conclude our class today. And make sure, of course, to include your location, so where you're watching from, and your name if you're going to ask a question. So we have our first question, Hannah. An attendee is asking if you can zoom in on Saturn and Jupiter for them.
Yes, so I'll do Saturn first. So Saturn, like I said, is a great ringed planet, and it's a gas giant that is yellow. And so as you see each of these rings, all of these are different combinations of of ice and rock. And yeah, it's quite a beautiful planet. And if I zoom out, you'll be able to see some of the other moons. But if we head back out, what do you mean I'm out of memory? Sorry, guys. I don't know what just happened. Yes. And if we go to Jupiter, it also looks pretty cool. And you'll see that there's all these little different storms around here. So all these different colors are different clouds, different storms. It's a big stormy planet. It's a never-ending constant hurricane.
So we have our next question from Sydney, and she would like to know how many dwarf planets are actually out there?
Oh my gosh. So that we have encountered probably 1,000 that I can think of off the top of my head, but we also haven't found all of them. And so we know that the majority of stars that we have seen that have planets is almost all the stars that we've seen. And so it is probably without a doubt that almost every star out there is going to have a planet. And so I believe probably they're not that common, but they are usually in their own little systems. So I would say they are more than we can count. Definitely going to be more than we can count in the entirety of the universe. So they're definitely not random. There's also sometimes these things called orphan planets, which means they are planets that are essentially plunged in darkness because they have lost their sun, either because they got knocked out of their orbit, their star died, or something happened where they are no longer having a home. And so a lot of those planets also are also dwarf planets. I don't know why that is, but that's just something that was found.
Had our next question, and this is from Alexandra, who would like to know, well, actually I should say she would like to be an astronaut when she grows up, and she's wondering, do you have any tips?
Oh, yeah. So I think that's fantastic. Definitely keep pursuing that dream. That's wonderful. There's a lot of different ways to actually become an astronaut. An astronaut isn't just someone who studies physics or astronomy. There are biologists, there's engineers, there's a chemist that was on there on the International Space Station. And there's just so many different things that you can do. I would just say keep trying to be healthy, be active. I don't know really what the requirements are with vision, but you really just want to do your best, keep trying, pursue that dream. Maybe when you get a little bit older and you're doing programs, there's a lot of things called internships. And so as you get older, you can actually apply for NASA internships and keep applying for those because they get you really into working with NASA, and you can keep trying to kind of get your foot in the door to get to that. But they actually just had astronaut applications, and typically they want adults with master's degrees at least. And so pursue your education. I would definitely say go to college, try to get your bachelor's in whatever, try to get your master's. You can really focus in on something that really interests you. Like me, I am interested in astrophysics. So exactly what we're talking about now is something that I'm very interested in. I like talking about stars and the different types of stars and what black holes are. And so I want to pursue my master's to be able to study that more and be able to apply that in space. And so I think that if that is something that you would like to pursue, definitely keep pursuing it. But pursue your education. Try to ask as many questions as you can. I think being a scientist is fantastic, but definitely being a good scientist is, don't be afraid to ask questions. Don't be afraid to fail. Failure is always going to happen. You shouldn't feel like if you experience failure or setbacks that it means that you're not going to succeed. That's not true. Just keep persevering, keep trying, and you're going to do a fantastic job.
All right, so we've got a couple more questions coming in, and just want to remind everybody that we've got about a little less than 15 minutes, so feel free to keep asking those great questions. Emma wants to know, how wide is space? So how much space?
Ooh. Wow, how much space? I love that question. I don't know, and I am so okay with saying that. Space is so big. We don't actually know. We don't even know if what we can see is the limit. So we typically measure space in terms of light years. So from where we are in Earth to where the furthest we've seen is 14 billion light years. That is 93 million miles times 14 billion. So that's really, really far. And we don't know if that is it. We don't know. And so space is really, 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 really big. And there are things in space called dark matter and dark energy, and we can't see them or detect them, but they're there. So we don't actually know how much of space is empty. It's a really, really difficult question to answer, but I encourage you, if you want to figure that out, I encourage you to try to study that as you get older. That'd be, oh my gosh, maybe one of you will find the answer to how big is space, or how old is the universe really, or what is dark matter or black, like can black holes become entrances to other universes? That would be so cool. Thank you for asking. That's a really great question.
Yeah, and I suppose it's getting bigger as the universe keeps expanding, right?
Yeah, I'm not going to talk about that because it's kind of scary, actually.
Well, we can go on to our next question. Teresa asked, how did the moon get made? So how did the Earth's moon get made? I'm assuming.
Ooh. Wow, you guys are asking such great questions. Oh, it makes my heart so happy. So there are a few theories, well, not theories, there are a few hypotheses, and that is a step of the scientific method. And so when we are asking questions, you want to test out these questions with a hypothesis. So a hypothesis would say, something that I want to test is, let's see. I think I can break this glass with my hand. So my hypothesis would be, I think I can break this glass with my hand. I would say, how am I going to test that? That's the next step. How would I test this? And say, well, I could try to hold it in one hand and try to crush it. I could try to hit it and see if I could break it. Or maybe I just leave it in my hand and see what happens. And then I take all of these different things that I've come up with, like their ideas and whatnot, I test it and I see if that works. But if it doesn't work, I keep trying to see if there's different methods. And if I keep trying it and it doesn't work, maybe I just got to try something else. And so when we have an hypothesis of, oh my gosh, Drew, what was the question? I got distracted by hypotheses.
No, it's a good answer. How did the moon get made?
Great. Okay. So our hypothesis is there are some ideas, some hypotheses of how the moon came to be. So one is that an asteroid, while the Earth was forming and very hot, came in. I love doing demonstrations. So we had the Earth and it was spinning and forming and all that. And then suddenly an asteroid came in, hit it. And so it's like spinning and all that. And suddenly it gets, as it's mixed up, and it releases and it gets caught. And so then it used to be closer. And now it's actually moving a little bit further away, which we do know this is happening. It's like moving further away. Another idea is that it was a captured planet, or maybe it was another planet that got too close to Earth and got captured, which means that it got too close to the Earth. And Earth's gravity, which is a force that says, you're really close to me and I'm going to pull on you. And we all actually have gravity, but we don't feel it because it's not that strong. It's canceled out by the Earth's gravity. So as this planet, it used to do this. Let me see if I can do this. So it used to be like this, but it got too close. And so instead of going out, it got caught in the Earth's gravity. And so now it orbits. There's a third one, but I don't remember what it was. But there's no set information as to how we got the moon, but there's a few ideas.
Yeah, so I think those are all great hypotheses or guesses, what we call scientific guesses. So next question, and we have maybe about 7 minutes left in our class today, so I want to urge anybody out there who wants to ask the final question to do so now, but we have 2 more right now, and Hannah, Autumn would like to know, what is outside of our solar system?
Ooh, love it. I can actually show you a little bit. So our sun is within all of these other stars. So you're seeing like all of these other things, like these little balls. These are other stars that are near us. And then as you keep going out, there's like all these different things, right? Whoa, what is this? We are in a galaxy. And this is the Milky Way galaxy, just like the Milky Way bar, except this came first. And we are one of thousands of stars within this galaxy. And our galaxy is just one of probably millions, if not trillions, of other galaxies. And these form local groups, and then those local groups of galaxies form superclusters, which are just all these really compact clusters of local groups and galaxies, and those form the universe. And so there are galaxies, there are supernovae, which are exploding stars, there's stars, gas, black holes, which are formed by stars dying as well. Yeah, there's just gases and different elements being made, which make up you and me, and we are made of star matter, and that's so cool that we come from stars. And there may be life out there, we don't know, but everything is out there, really.
So I think we just have a few minutes left before we're going to transition over to our class for juniors. And I just wanted to ask, two people are actually asking, Emma and Grace are asking, what are black holes?
Oh, I love this. Okay, so black holes are these points in space or anything really that have, okay, let's say I have a star in my hands, right? And this is a regular star, and it, as it's dying, it's expanding, and you guys can actually watch my class on that, lifespan of a star. Shameless plug. You'll find it on our website. So as a star expands, as it's dying, eventually it can no longer expand anymore because it runs out of fuel and it collapses in on itself. So all of that mass, the weight of the star, which you and I have mass too, but we call it weight because we calculate our weight by our mass times the effect of gravity that we're feeling from the Earth. So the mass of that star all collapses into a single point called a singularity. And so you have all of that mass that's crushed into such a small portion that it has a really big gravitational pull, which, as I said before, it's a force where it's a force of attraction between objects. And so all of this gravity starts to fall in and on itself, and it just becomes a space of nowhere, really. The force of gravity becomes so strong that not even light can escape it. So they're just like these holes that are completely dark and black, and we don't really know what goes in them. So yes, that's a black hole. Anything can make a black hole, though, theoretically.
Yeah. And I think we have time just for our very last question here, and it's probably a topic we can't answer in full this time, but we'll definitely come back to it in our next class next Friday for Brownies. But Kaylee would like to know, how do stars get made?
You guys, I love your questions. I can't really answer that without, I need a lot more time. So I actually encourage you to watch the class, The Lifespan of a Star, that we have on our website. It's the fairbanksmuseum.org. And for our virtual learning, you'll find it in the archive, because I answer that question in full. And you'll find out more about how stars explode. Well, they grow and then they die, and they can bring new life. So, but essentially they're formed by collapsing gas and matter due to gravity, and then they burn. That's a really short answer, but I encourage you to look that up.
Yeah, that's a great answer for the amount of time we have left. We're going to actually switch over now to our juniors who are maybe waiting out there. So thank you so much to all of you Brownies who tuned in today to work on your badge. We're excited to have you here with us, and we're excited to be partnering with the Girl Scouts of the Green and White Mountains on this class. Of course, we're a tiny little museum called the Fairbanks Museum and Planetarium up in St. Johnsbury, Vermont. We encourage you, of course, to take advantage of all of our offerings online that Hannah mentioned. They're all free. So without further ado, I wanted to just thank everybody and give a warm thanks to Hannah for this class. And if you're a junior and you're out there on the Facebook page waiting for your broadcast, stay tuned. We'll be back in just a minute. All right, so I stopped the broadcast. And Carrie, I'm just going to make you the host again so that you can start the next live stream.
Okay, brownies.
And
Okay, I'm going to quickly grab some water. I am completely parched.
Okay.
I'll be back in like a second.
Perfect. And Carrie, I'm just going to unmute you so you can talk if you need to, if I can. Oh, actually, no, I made you the host first again. Oh,
that was fantastic.
Oh, thanks, Carrie. That's
yeah, that went really well.
Yeah, I meant to say that they should. Well, actually, I guess I did say that they should tune in again next week. So.
Yeah, no, we can do that again. All right. So I see you made me the host again. So I'm going to go live on Facebook.
Okay.
1 second, it's just opening up. Hannah, that was fantastic.
Oh, thank you.
Just let us know when you're ready, Carrie, and I can.
Sure, it's just popping up.
Yeah.
Oh, I'll stop my share. Sorry.
Good idea.
It's just thinking about it. 1 second.
Essentially, we'll be hearing the same thing again. So.
That's a great website. That's really cool.
Isn't it? Oh, I love it. There's another website too that I can't remember off the top of my head, but it's for exoplanets, and so you can't actually see our solar system.
Oh.
So sad because it's great. But let me see if I can make this big. I did not like that I couldn't see the whole thing.
I'm gonna it just closed out. I'm gonna try it again. It seemed to be taking. Oh,
the perk. Cool.
it's just scrolling. Hold on.
Did you hit the go live part? That usually is what stops that.
It actually hasn't even gotten me to that screen yet. It's just black scrolling before I even get there.
Oh. Wow, technology.
Love it.
So if we need to, we can restart our Zoom meeting.
If we need to. Should we try that?
Is it not working for you still?
No, it's still just scrolling.
Okay, I'm just gonna I'm gonna stop the meeting. Actually, you have to stop the meeting, Carrie, and then I'll.
Because I'm the host. Okay, hold on. All right, end meeting.